Okay, grade 7, these are 9 questions with algebra, 9 equations where you have to solve for x. This is very important that you're able to do this for your chapter on linear relations, because as we graph and as we examine tables of values and as we determine equations that match these particular things, you need to be able to isolate variables with 100% accuracy every single time. So in the first line, we have one-step algebraic equations. And in the second line, we have one-step algebraic equations. And in the third line, we have two-step algebraic equations. Now, what that means is in the first question, we have just a constant and no coefficient, or a coefficient of 1. So what that means is if I'm going to isolate the variable using opposite operation, I just have to get rid of the constant, and I'll know what the value of x is. In the third question, I don't have a constant. There is no plus or minus value. But what I do have is a coefficient. Once I get rid of that coefficient, I will know what the value of my x is. In the fifth question right here, I don't have a constant. There is no plus or minus to it. But I do have a coefficient. And that coefficient is not 4. That coefficient is a quarter. And as we look at this question, I don't have all of x. I just have a quarter of x. Or a quarter of x. Both this expression and this expression are the same amount. I don't have all of x, I just have a quarter of x. Once I get rid of that quarter, I will know what the value of x is. And in the last line, we have a two-step equation because I have both a constant and a coefficient, and I have to get rid of both of those to know what the value of my x is. And I know from experience when we did the chapter on algebra, I'll always get rid of my constant first because it's easier, and then get rid of my coefficient second, and then I'll know what the value of x is. So for all of these questions, we're going to employ opposite operation to isolate. So if I want to get rid of this minus 3, I'm going to do the opposite of whatever it is to get rid of it. That's going to create a 0 pair. I'm going to be left with x on the left and the value of 5 on the right, and I'll know that x is 5. Okay, so x is 5. What number take away 3 is 2? It's 5. So if I went back in time and just did it by inspection, and I was to cover this up, and I'll take my handy-dandy red square of knowledge. If I was to take this red square and I was to place it over top of the x and say, what number does that red square have to be in order for this equation to be true, you would say, what number take away 3 is 2, and we know it's 5. So by inspection, I know it's 5. And by opposite operation, I also was able to confirm that it was 5. In the next question, if I was solving by inspection, I would cover up the x and say, what number do I add 5 to it to get the answer 4? This one's a little tricky by inspection because you have to know the answer for that is negative 1. Negative 1 plus 5 would give you a positive 4. So by inspection, it's kind of tricky. But if we take away that red square and then use opposite operation, if I want to get rid of this constant that's minus 5, I'm going to subtract 5, or plus 5, I'm going to subtract 5 from both sides. That creates a 0 pair. X is equal to whatever a positive 4 and a negative 5 combined to be. 4 positives and 5 negatives gives you negative 1. Okay, the next question. I'll go back in time here just to erase that part there. So the next question, if I cover that up and say, what number multiplied by x, or sorry, wrong way, 2 times what number is 7? Now for some of us, that's a tricky question. But 2 times 3.5 is 7. So we know the value of x is 3.5. But if I solve it by opposite operation, I'm going to see this as being 2 times x, or multiplied by x, and the opposite of that is dividing by 2. So I'm going to divide both sides by 2, and x will equal 3.5. In my next question, if I cover up the x and say 10 times what number is 12, some of you know that x times 1.2 is 12 because when you multiply by 10, you move your decimal one place over. So if it was 1.2 and you move your decimal over one place, you'd get 12. But if I solve with opposite operation, divide both sides by 10, and x will equal whatever 12 divided by 10 is, move your decimal one place over when you divide by 10, and you get 1.2. In your next question, what number do you divide by 4 to get 1? The answer is 4. 4 divided by 4 is 1. So we know that x is 4 by inspection. Using opposite operation, what I want to do is I want to do the opposite of dividing by 4. So if I multiply this side by 4 and multiply this side by 4, I'll get x on this side, and I'll get the product of 1 and 4 on this side, which is 4, and I solved it using opposite operation. X is 4. In my next question, if I ask the question by inspection, what number divided by 10 is 100? A lot of people might have made a mistake here. It's 1,000. X is 1,000. 1,000 divided by 10 is 100. But if I solve it by opposite operation, I'm going to use the opposite of dividing by 10, which is multiply by 10, and multiply by 10. That's a zero pair, and x will equal 1,000. In the 3 questions at the bottom, these are two-step algebraic equations. And I'll take my x still, try and solve it by inspection. Make this x a little smaller. 2 times what number, then take away 5 from it, is 17. This is trickier. Two-step equations become more difficult to solve by inspection. So what we usually do is, in these situations, if you can't solve it by inspection, just use opposite operation when you get to two-step equations. So the first thing I always want to get rid of is my constant, which is minus 5. And I'm going to use the opposite of that by adding 5 to both sides. 2x will equal 22. And now I have, it used to be a two-step equation, but because I got rid of my constant, I now have a one-step equation. Instead of having 2 multiplied by x, I'm going to use the opposite, which is dividing by 2. So multiplying by 2 and dividing by 2 are opposite. X will equal 11. Now what you should always do once you've solved it is go back and try that inspection thing again. So if I treat this x as 11, then 2 times 11 is 22, and 22 take away 5 is 17, so it works. By inspection, or by substituting that x for 11, it works. In the next question, you have a number divided by 5, then take away 1 is equal to 3. Hard by inspection, not sure. But if I was to think about inspection, I could make that whole thing into a number. I could ask myself, what number take away 1 is 3? And most of you know that that number has to be 4. So I know that this red box has to be equal to 4. So what I'm really asking myself is, what number divided by 5 is 4? What number divided by 5 is 4? 20. So I know that x is 20 by inspection, right? So it is possible to solve these by inspection, but you just have to treat the whole thing as being a number. So I've solved it by inspection. I know that x is 20, but I'm going to use opposite operation to confirm my inspection. Add 1 to get rid of your constant. You now have a one-step equation. Multiply both sides to get rid of the divide by 5. And x does indeed equal 20. And in the last question, if I take that red box one more time, cover it up, and say, what number take away 3 is 3? We know that red box has to be 6. So whatever's under that box has to be equal to 6. So what number divided by 100 is 6? 600. So we know that x has to be equal to 600 by inspection. Go back here and use opposite operation. Get rid of my constant first. X divided by 100 will be equal to 6. Multiply both sides by 100. Those are opposite operations. X equals 600, just like we got with inspection. Okay?